Hello students, in today's lesson we are going to continue talking about forms of rational numbers, so you can call this part 2. Today we're going to talk about equivalent fractions, decimals, and percents. So our essential questions are, what are fractions, decimals, and percents? How do you define them? How do you describe them? And how can I write fractions and decimals and percents? How can I convert between them? So I'd like you to pause the video for a couple minutes and think about what you know about fractions, decimals, and percents. Maybe what do they look like? How would you define them? When have you seen them? Or any other thoughts that come to your head. Fractions, decimals, and percents are all ways to write a ratio to show the number of parts out of the number that make one whole. You may have gotten a worksheet back that said you got a 9 out of 10. That meant you got 9 questions out of the 10 right. It described how many parts you had out of how many made the whole worksheet. You may have said, oh, that's a 90%. That's another way of looking at your grade. 90 parts out of 100 would have been correct. So let's look at the vocabulary terms. First of all, what is a fraction? A fraction is a ratio that compares the number of parts to the number in a whole. The number of parts is called the numerator, and the number that make one whole is called the denominator. A decimal is a ratio that compares the number of parts to the number in a whole, same thing, but it uses place value. The second amount has to be a power of 10. How many out of 10? How many out of 100? How many out of 1,000? How many out of 10,000? A percent is a ratio that compares the number of parts out of 100. For instance, when you read that percent symbol, it literally means out of 100. So if you got a 95%, you got 95 out of 100. All three, fraction, decimal, and percent, can describe the same relationship just in a different way. So if Jen earned a 95% on her test, we could say that that was 95 over 100. We could say that that was 0.95, since the 5 would be in the hundreds column. Or we could say that that's 95 out of 100. Let's now look at how we can change from a fraction to a decimal. Here we have a fraction, 35 out of 40. If we want to change from a fraction to a decimal, we need to understand what this fraction bar represents. What operation does a fraction bar represent? It represents division. And when we divide a part by the whole, the part needs to go inside. Remember, it's like playing chicken in the pool. The one on top always falls in the pool. That's how you can remember what number goes inside. So 35 goes on the inside, 40 on the outside. Will 40 go into 35? No, and that makes sense because this fraction is less than one whole. One whole would be 40 out of 40. So to continue dividing, we need to add a decimal and a 0, showing that it is less than 1. 40 will go into 350 how many times? 8 times, which is 320. Think 8 times 4 is 32 and put a 0 on the end. That leaves 30 left over. Add another 0 and bring down so that we can continue dividing. 40 goes into 300 7 times, which is 280. There's 20 left over. Add another 0, bring it down. 40 goes into 200 5 times. 5 times 40 is 200. So we have nothing left over and nothing more to bring down. So 35 out of 40 is the same as 0.875. So we've just proven that 35 out of 40 is the same as 0.875. How do we know what percent that would be? Now we want to take that decimal to a percent. Remember, percent literally means out of 100. So if you look at this decimal, where is the 100th column? Well, this is the tenths, this is the hundredth. So we need the first two digits. Well, there's 3 here, so we will round it. Look to the right. How does the 5 affect the 7? It rounds it up. So this is about, the symbol means about, 0.88 or 88 hundredths or 88 out of 100. So this is the same as 88%. If you earned a 35 out of 40 on a test, you would earn an 88%. Now, let's reverse it. How could we do the opposite? How could we start with the percent, go to the fraction, and then to the decimal fraction. Let's start with 64%. Remember, the percent literally means out of 100. So this means 64 out of 100. If you think about a decimal, we know this is going to be less than a 1 because it's less than 100%. You have the tenths column, and then you have the hundredths column. This hundredth column literally means the same thing, out of 100. So we write 64 hundredths. If it were just 4%, the 4 would still go here, and we would put a 0 in the tenths column. So now we have shown that 64% is the same as 0.64. Remember, this is the hundredths column. This is a percent symbol. It both literally mean out of 100. So as a fraction, we would say that is 64 out of 100. Here is a fraction that represents this percent. This fraction could be reduced. 64 out of 100 could be reduced. We could reduce it by 2 to get 32 out of 50. We could reduce it by 2 again to get 16 over 25, which is as reduced as we can get. This is sufficient for now. We will practice reducing later. So let's look at this number line and let's try to figure out what A equals. Now, look along the bottom. What forms are these written in? Fractions. Even 1 is a fraction, 1 out of 1. Even 0 is a fraction, 0 out of 1. We want to know what fraction is 30%. Well, remember, the percent symbol literally means out of 100. So it means 30 out of 100. So A is equal to 30 out of 100. If you wanted to reduce it, you could reduce it by 10 to get 3 out of 10. So A could also equal 3/10. Pause the video. You try to see if you can figure out what B would be. While you were working, you should have got that B is equal to 46%. You should have divided 50 into 23. When you did, it would go in no times, so you would add a decimal and a 0. It would go in 4 times, which would be 200. You would have 30 left over. Add another 0 and bring it down. 50 goes into 300 6 times, which is 300. This is our decimal, not our percent, but we know that this means out of 100. So it would be equal to 46 out of 100, or 46%. Let's try an application. Think Mr. Coons' class. A molecule of water is made up of 2 atoms of hydrogen, so that's important information. We have 2 hydrogen and 1 molecule of oxygen, so we have 1 oxygen. What percent of the atoms of the water molecule is oxygen? Well, we have 1 oxygen, that's the part that we have, out of how many? How many make 1 whole? We have 1 oxygen, 2 hydrogen, so that makes 3 altogether. Divide it. 3 will not go into 1, which makes sense because you can't have more than 100% oxygen. 0.0, 3 goes into 10 3 times, which is 9. So we get 1 left over. Add a 0, bring it down. 3 goes into 10 3 times, which is 9. Again, we have 1 left over. Add a 0, bring it down. What's going to happen? It's going to keep repeating the 3. How many, and that's okay, how many digits do we need here to make a percent? We need 2. So look to the right. How does this 3 affect this one? Well, it keeps it the same. So this is the same as 0.33 or 33%. So what percent of the atoms of a water molecule is oxygen? This water molecule is 33% oxygen. That's how you would restate your answer. Of the 20 highest mountains in the United States, 17 are located in Alaska. What percent of the highest mountains in the United States are located in Alaska? Well, we'll start with a fraction. What fraction would represent the mountains in Alaska? And that would be 17 out of 20. We want to know what percent. So we will need to divide 20 into 17, which will go in no times, which makes sense because it's not all of the mountains are in Alaska. 20 will go into 178 times, which is 160. There's 10 left over. Add a 0 and bring it down. 20 will go into 100 5 times, which is 100. So we get the decimal of 0.85. That means 85 out of 100. So 85%. And if we were to restate our answer, 85% of the highest mountains in the United States are located in Alaska. Take a moment, try this problem on your own, and it will be a problem that we will look at in class tomorrow. Michael Beasley shot 25 times, so that's how many in all, and he made 23 shots. How could you represent his made baskets as a fraction, a decimal, and a percent? Have each one. We're going to skip that example for time. So let's summarize. What does the word equivalent mean? Equivalent means equal in value. We've had that as a Daly's word before. Equivalent means equal in value. What are the equivalent forms of fractions? How could you write a fraction in a way that's equal in value? You could write it as a decimal or a percent. They are equal in value. And how do you change from a fraction to its equivalent forms? How would you change from a fraction to a decimal? You would take the fraction and divide it to get the decimal. How many digits of the decimal will you need to look at to get the percent? You will need to look at the first 2 digits because that's where the hundredths column is. Great job, students, and we will look at this more in depth tomorrow and have some practice. Have a good night.